Let us look at the concept of inverses. So, inverse image of an element. So, F maps A to B, then F of A is equal to B. Now, here B is called the image of A under F, and A is a pre-image of B. Now, how to show B is mapped from A by which elements? Or, in other words, is there a function which will take the input as B and tell us which elements of A maps to B? Now, the way that is written is F inverse of B is equal to the set of A, where A is in the set A and F of A is equal to B. Now, F inverse of B is the set of all those elements of A which have B as their image. So, A is called the inverse image or pre-image of the element B. Now, inverse image of a subset. Basically, we are taking inverse image of an element a little bit forward. So let's say we have a function f which maps A to B, and there is another set C which is a subset of B. Now this would imply that the F inverse of C is also a subset of A. We have a mapping F from A to B. C is a subset of B. F inverse of C is the set of pre-images in A of the elements in C. So if C is a subset of B, then F inverse of C is a subset of A. Now let's look at inverse of a function. If F maps A to B is a bijection, that is 1 to 1 and on to, for every B, there exists a unique A such that F of A equal to B. Now we can define a mapping G which maps B to A such that G of B is equal to A. And this G of B can be written as F inverse of B, which will give us A. So here F inverse is called the inverse of F. If F is bijective, then F inverse exists and is also bijective. Now let's look at some examples of inverse of a function. Let's take the first one. F of x equal to x cube. Its inverse would be what? Its inverse would be cube root of x. Second one, f of x equal to 2x plus 1. Now what will be its inverse? The first one was pretty straightforward. Now here, let y is equal to 2x plus 1. We write this in this form. Y is equal to 2x plus 1. Substitute x with y and y with x. So basically we are converting this equation by writing x wherever y is and writing y wherever x is. So x is equal to 2y plus 1. Now we solve for y. So 2y plus 1 is equal to x. That means 2y is equal to x minus 1. Y is equal to x minus 1 by 2. Now let g of x be equal to x minus 1 by 2. So we are writing using the function notation. So here g is the inverse of f, also denoted as f inverse. Now let's look at the third example. X square plus 2x plus 3 is f of x. Let y be equal to x square plus 2x plus 3. Again, x and y, we exchange. Y square plus 2y plus 3 minus x equal to 0. A quadratic in y, which is what we have now. We use the quadratic formula to solve for y, because that is what we have to do now. So y is equal to minus 2 plus or minus square root of b square minus 4 times 1 times 3 minus x divided by 2 times a, which gives us y is equal to minus 1 plus or minus square root of x minus 2. Now, y cannot be written as a function of x because one value of x gives two outputs, which makes it one too many. So if it is one too many, we can't write it as a function. And that is happening because of this plus or minus. Remember, a function must have only one output for each input. Now, how to make it a function? The problem is that plus minus sign. So we choose one branch. So let's take the positive branch. So y is equal to minus 1 plus square root of x minus 2. Notice that here, for this to be real, x minus 2 under the square root has to be greater than or equal to 0, which means x has to be greater than or equal to 2. So working backwards, y plus 1, where is that? Yes, minus 1 we take it to the other side, or here we can do that. Y plus 1 is equal to square root of x minus 2. Now, x is greater than or equal to 2. That means it is greater than or equal to 0. So y plus 1 is going to be greater than or equal to 0, which implies y is greater than or equal to minus 1. See, all this we are doing it to figure out what should be the restriction on the original function. But x got replaced with y. So therefore, x has to be greater than or equal to minus 1. So now we have f of x equal to x square plus 2x plus 3. And on this function, we are putting the restriction that x is greater than or equal to minus 1. And its inverse, that is g of x, which is also written as f inverse of x, is equal to minus 1 plus square root of x minus 2 with the restricted domain of x greater than or equal to 2. Now, if we choose the negative branch, that is minus 1 minus square root of x minus 2, what happens to the restrictions? Look at this and work it out. Pretty straightforward it is. Now let's look at the fourth one. We have f of x equal to sine of x. Now sine of x is periodic. Its values keep going from minus 1 to 1. That is, its domain is all real numbers and range is minus 1 to 1. To find its inverse, we would be exchanging the domain and the range. Why? Let y is equal to sine of x. Exchanging x and y, we get x is equal to sine of y. And that's why we are going to exchange the domain and range. Now the domain of the inverse is minus 1 to 1 and range of the inverse is the set of all real numbers. In that case, we would end up with one-to-many relationship between x and y. So it cannot be a function. To make it a function, we restrict the domain of the original function to a suitable interval, which makes its inverse a function, that is, gives one output for each input. And to do that, we can choose any interval, but the standard interval chosen for sine of x is minus pi by 2 to pi by 2. Now the above interval is not for sine of x, but applied only when we are taking the inverse of it. So that was inverses. Inverse of an image, inverse of a subset of images, and inverse of a function. That's it for now. Bye.